Well, you learned what a covalent compound is. Remember, two nonmetals. You also get to learn some of the naming techniques and how it differs than an ionic compound. So let's get started. So our covalent compounds are different than ionic. Ionic uses charges to figure out what the formula is, and you can only have that one set ratio between the two atoms, between the two elements, because they have different charges, and the charges determine the ratio. But covalent compounds share electrons, and they can actually share different variations of that ratio between those two elements. So let's look at an example. These, you should know these. We have CO and we have CO2. Both compounds of gases you're probably pretty familiar with. Do you know their names? So CO is carbon monoxide. CO2 is carbon dioxide. Well, let's see, based on the fact that you already knew those two gases, let's see if we can link it to the nomenclature for those particular compounds. Now, nomenclature is just a big fancy word. It means that we're going to have some sort of systematic naming. There's a rhyme or reason to do what we're doing. There are some rules that are associated with this. For your covalent compounds, for your metal and your nonmetal, you have to indicate how many atoms of each element there is. Now, the way that we indicate the number of atoms is by using Greek prefixes. Mono, di, tri, tetra, penta, hexa, hepta, octa, and it goes on just like algebra class did. So back up to our two examples. We had one carbon in each of those compounds. Now, one technically is mono, but if that one is on the first element, a lot of times we leave it off. So we're just going to say carbon. Now, if it would have been 2 or 3, we would have had to have said the prefix. The last element, we always put the prefix on it. For the first example, CO, there's one oxygen. We still change the ending to "ide", but we're going to add the prefix mono, carbon monoxide. For CO2, it's carbon dioxide. There's 2 oxygen that we used. So how about this one? S2F10. 10's not even on there, but I think you can do it. So 2 nonmetals. There's 2 sulfurs. So 2 is disulfur. And then the last part, 10 is deca. Hopefully you knew that one already. I only went to 8 on this slide. 8 is octa, 9 is nona, 10 is deca. Deca fluoride. And we changed the ending to "ide". Notice we had to put the prefix on our first element because it wasn't just one. Let's try another one. Let's try, oh my, I'll just make something up. Into I3. So 2 N's, that's going to be dinitrogen, and 3 is tri, and I stands for iodide. Now, if you have 2 vowels that are side by side, sometimes they drop one of them, sometimes they don't. I'm not going to worry too much about that. I'm going to go ahead and put both of the I's. I can't remember if I'm supposed to or not, but it's okay. Dinitrogen triiodide. Ooh, that sounds kind of weird. Now, with these, it's actually really easy to go backwards. If you know the name, it's really easy to figure out what the formula is. For example, you could have, let's try this one. Dioxygen difluoride. oxygen difluoride. So on this one, I have oxygen, and how many are there? Yeah, we use the prefix di, so that means that we have 2 oxygens. And then I have fluoride. Fluoride is just fluorine. And how many fluorines are there's 2 fluorines also. This is a really, really brief and quick introduction to naming. You will see some naming techniques used later on. I would like for you to become beginner level, kind of understanding some of the differences and how to start naming. There will be a little bit of that on the test, but I'm not expecting you to be an expert at this point in time. So don't worry too much about it, but don't skip it either. Now, there's also some cases where you have what's called a polyatomic ion. So let's look at our term here. Poly means many atoms that are an ion, and an ion means that it has a charge, that it's gained or lost electrons. So a polyatomic ion is a covalent bond. So you'll see that we have a bunch of nonmetals together that have, for some reason, that molecule gained or lost electrons, and then it becomes an ion. Now that ion will go ahead and react to form an ionic bond with something else. So it's kind of unusual. You have both ionic and covalent bonds all occurring at the same time. Now, with what I just told you, you might decide that you need to go take a nice relaxing long bath, and maybe on the way you grab some Epsom salts. And then you think, oh, wait a second, we're in chemistry class. Let's see if this has like a chemical name. And what you'll find is that Epsom salts have this formula, MgSO4. Well, Mg, that's magnesium, that's a metal, magnesium. And this SO4 thing, that is a polyatomic ion. If we look down here at the very bottom of the slide, there's our SO4. Notice it has a charge associated with it. It gained 2 electrons, so it formed a bond with magnesium that lost 2 electrons. Oh, it's so confusing. But that SO4, we call it a sulfate. So when we name this compound, we actually call it magnesium, and then you just put in that polyatomic ion name, magnesium sulfate. Another example. So, of course, I'm from Kansas. We have lots and lots and lots of farmland around here. And one of the fertilizers that sometimes people will use contains ammonium nitrate. Now, ammonium nitrate is of special concern because even though it can be used in fertilizer, it can also be used in explosives. So here's that formula for ammonium nitrate. Let's see how they came up with the name. Now this one, it looks like it's just a bunch of nonmetals, but it's really long and it's not carbon based. So this actually has 2 polyatomic ions that they put together. The first thing, that NH4, there's NH4. NH4 is ammonium. So we just write out that word, ammonium. And then the NO3, there it is. The NO3 is nitrate. And again, we can only use that when they become polyatomic ions where they've gained or lost electrons, where they have a charge that's associated with them that's then used to form a compound.